Hi, Amanda. This is Brian. I do want to go over these lessons with you, so this would be probably a good review for your ready test. The first one I want to go over is in lesson one. Again, feel free to pause this video at any time and rework some of these problems. On lesson one, number 11 and 13, those answers are incorrect. Um, these are absolute value questions. Those vertical bars mean absolute value. So absolute value means to find the distance a number is from zero. And remember, distance is always a positive value. So it's really important to us that distance is always a positive value, unless of course we're talking about zero. Zero is neither positive nor negative, but other than that, it's an always situation. Always be suspect of the word always. And when you take the GD test, that's one of those flags. That's usually never choose that answer. So when I want to take the number 11, if I want to take the absolute value of -9, what that's asking is how far is -9 from 0? And so you'd have to move like 9 to the left to get there. So that means the distance is going to be a 9. Such that when you have absolute value, the answer will always come out as a positive value. Now, of course, you got 12 correct. The absolute value of 0 is 0. But if you look at 13, the absolute value of -18, again, absolute value means how far from 0 is -18. We'd have to move 18 to the left of 0, which means your distance would actually just be 18. So again, if you see absolute value, the answer always comes out as a positive value. That's important. The other questions I want to kind of talk about on lesson one is subtraction. Again, if you're using a calculator, you can type in 0, take away a -12 in the calculator. And what you're going to find out, that's not the same thing as 0 plus -12. That's not a true statement. Now, you are allowed to change a subtraction problem to addition, but you got to do three things. You got to use what we call the KCC method. So you got to keep, change, and change. So if I am going to rewrite subtraction as addition, what you're allowed to do is you're allowed to keep the first number. So I'm allowed to keep the 0. I have to change subtraction to addition. And I also got to change the second number. Since the second number is negative, I got to change it to a positive. So what I should have is 0 plus 12. So if you type in a calculator 0 take away a -12, that should be the same thing as 0 plus 12. But it's not going to be the same thing as this. This is false. So watch out if you rewrite subtraction problems. If you rewrite them, you got to rewrite them correctly. Otherwise, just leave the subtraction problems and just use your calculator. So if I want to rewrite -12 take away 10 correctly, I keep the -12. I'm allowed to change subtraction to addition as long as the second number also changes. Notice how the second number is a positive 10. So positive 10's got to turn into a -10. Now those two are equivalent. So if you put -12 take away 10 to your calculator, that should give you the same thing as -12 plus -10. They should both give you a -22, either way you do it. But this is not correct. That is not the same thing as -12 take away 10. So watch out. If you rewrite a subtraction problem, make sure you rewrite it correctly by keeping and changing and changing. So again, I keep the -12. Subtraction has to change to addition, and the 10 has to turn into a -10. That's the way that would work. So this is in, I believe, lesson 4, question number 42. You're supposed to evaluate the following. So the problem was we have -5a plus 2b minus 6c, and we want to evaluate that when a is equal to -6, b is equal to 4, and c is equal to -2. So when you did this problem, you started out correctly. You substituted the -6 in for a, you substituted the 4 in for b, and you substituted the -2 in for c. At this point, if you want to, you could just use your calculator and work it out. You don't have to use the order of operations. But on the GD test, this may be on the side that you don't get a calculator. So keep that in mind. So when you did this, you know, a negative times negative is actually a positive, and 5 times 6 is 30, so that's correct. 2 times 4 is 8, that is correct. The minus sign comes down, and 6 times negative 2 is negative 12. You know, 30 plus 8 is 38, but here's where the catch is. You know, when you have this 38, you still got to take away this negative 12. If you're going to change subtraction to addition, you have to rewrite it as 38 plus a positive 12. That would be correct. Okay, but notice how they're subtracting a negative 12. That's not the same thing as taking away a positive 12. So there's where the mistake happens, is we lost this negative symbol right here. We lost that negative 12. Watch out for that. But I am allowed to change subtraction to addition, but I got to KCC it. So I could say, keep the 38, change subtraction to addition, as long as I take the opposite of negative 12, and that would be a positive 12. So 38 plus 12 would have been the correct pathway, and that would give you then, what would that be, 50? So 50 would be the answer to that problem. So I think that was the only thing that you missed up on lesson 4. And 2 and 3 were good, so I didn't see any problems there. So Amanda, this brings us to lesson 5, where we were solving some equations. 50 and 51 you got right. Notice how to remove the parentheses, you had to multiply the 3 through the parentheses, and that gave you this 3 times x is 3x, and 3 times 7 was this 21, and minus 21, and that equals negative 15. And since you saw subtraction, you knew to get rid of that 21 there, you had to use addition to make it go away. So you added a 21 on both sides, and that gave you 3x equals 6. And since the 3 is connected by multiplication, you divided both sides by 3 and got x equals 2. That is perfect. But if I look it down on 52, you will see that you did not follow the same game plan that you did on number 50. So again, you can pause the video if you want and see if you can work 52 out on your own. Otherwise, you can just kind of watch me try to solve it here if I have enough room. So again, when I multiply the 5 through the parentheses, like you were doing, I got to multiply the 5 to both of those terms. So 5 times 3x is going to be 15x, minus then 5 times 7 would be 35. Now the parentheses are no longer there. You have plus 2, and then that equals then this 7x plus 7. The minus 35 and the 2 are like terms, so remember, that's the same thing as plus a negative 35. So it's the same thing as then 15x plus then a negative 33. And that's going to equal then this 7x plus 7. Again, we got to get the variable on the same side. We pick on the little guy, so I'm going to pick on the 7x, so I have to subtract the 7x on both sides. And this is going to give me then 8x plus then negative 33, and that's going to equal then just the 7. And then to make this negative 33 disappear, you got to use a positive 33. So I have to add a 33 to both sides. And therefore you have 8x equals 40. And then you divide both sides by an 8, and then you'd have x equals then 5. That would be the solution to that problem. So again, remember when you multiply through the parentheses, you got to multiply to both pieces, and for some reason you did not do that there. You still got a 7 present here. That should have turned into a 35. So when I look at this problem here, again, it's the same concept. You got to multiply the 7 through both pieces. So if I do so, I should have 7x minus 7. And when I multiply the 2 through both pieces, I should have then 2x plus 6. Plus then, I got to multiply the 4 through both pieces. That's going to be 4x minus then this 28. So then 7x minus 7, those are not like terms, so they just come down, but the 2x and the 4x are like terms, so that becomes a 6x. And this is actually a negative 28. So a 6 and a negative 28 is actually going to give me a negative 22. So then I have to solve for x by getting x on the same side. So again, the 6x and 7x, the 6x is smaller, so I subtract a 6x on both sides. So I have x minus 7. equals negative 22. And then since I see subtraction, I got to use addition. So I add a 7 to both sides. So I should have then, let me clear that up a little bit. Let me make that a little bit neater. So I had to add a 7 to both sides there. So the x's come down, and then negative 22 plus 7 would be negative 15. So negative 15 would be your solution to that. So again, you can be using your calculator for those calculations like you have been doing, which again, that's perfect. So that's where that one went wrong, is you did not bring the number through the parentheses correctly. So the next lesson, Amanda, we're going to look at is lesson 6. And again, you were doing a lot of this correctly as well. So again, you're making a table. And we kind of gave a hint that y equals 4 is the same thing as y equals 0x plus 4. Because remember, we're using this form y equals mx plus b. And since the x is missing, that means the coefficient of x had to be a 0, so that m had to actually be a 0. And remember, m stood for the slope, and the b stood for the y-intercept. So in our table, we can pick 0 for x, and then we have 0 times 0 plus 4, which would just be 4. If I put a 1 in, 0 times 1 plus 4 would be also 4. And if you put a 2 in, 0 times 2 plus 4 would also still be 4. So that was our table, and I believe you had the table correct on that. So 23 you had correct. So the order pairs would be 0, 4, 1, 4, and 2, 4. So you had, I think 24 was also correct. Where we went awry is the graph. Remember, the first number is your x direction, and the second number is your y direction. And remember, this is your x-axis, and this is your y-axis, and you should be able to see x and y on those. So remember, the first number is how you move left and right. Since that's a 0, you do not move left or right. And then the 4 tells you to move up 4. So the first order pair should be at 0, 4 would be located there. 1, 4 would mean you'd move to the right 1 and then up 4, so it'd be located about here. And then 2, 4, you move right 2 and then up 4, and it'd be like there. And then you would draw your line through there, and your graph would look something like that. I believe on one of your sheets you actually had that, but I just couldn't really make it out. But here, something happened, and that's no longer the case. So on question 27, well, actually, notice that there's also a question 26 there. Remember, the slope is the coefficient of x. And if I want to identify the slope of this equation, the slope is simply going to be a -2. I don't have to do any math there. That's just recognizing. So if we're in this form, y equals mx plus b, the slope is simply the number in front of the x. And remember, slope stands for that rise over run stuff. So if I was going to use it, I'd have to make it a ratio, -2/1, if I was actually going to graph the ratio. But in simplest form, it's simply a -2. Now 27, we were asked to find the slope of a line passing through 6, -1, and -2, 4. And you used the formula, slope formula, and you typed in 4, take away -1, which is correct. And you also had -2, take away 6, which is correct. So if you wanted to, you could just put that in the calculator as it is. Again, you could use the N over D button on that, which would then create you a format of a top and bottom. So then you could just type in 4, take away -1 on the top, and you could type in -2, take away 6 on the bottom, and then just hit enter, and that should give you the answer to that problem. What you also could do, though, is if you rewrite this, 4 take away -1 really means 4 plus 1. Because remember, if you change subtraction to addition, that negative number has turned into a positive number. So you should have 4 plus 1. And -2 take away 6, that should be the same thing as -2 plus a -6. So what I should have then is 5 over -8, or in other words, -5/8 would be the slope to that problem. So that's what we're looking at there. So again, I don't know what happened on the top, but you did get the 5, but by rewriting it as addition, you should have had a negative there, and that should have been a positive, because 4 plus 1 is 5, but -2 plus -6 actually is not a 4. It's actually a -8, and that's where the mistake happened, is right there. That's where the error occurred, was in that area. But if you left it just like this and put it in the calculator, that would be perfectly okay as well. Let's see. So this is now lesson 7, a few questions off of here. At a fabric store, Melissa sold 8.5 yards of fabric to a customer. If the material is cut from a boat of fabric containing 23 3/4 yards, how many yards are left on the boat? So what you picked up on is, this is a subtraction problem. So 23 3/4 minus 8 1/2. And when you put that in the calculator, it looks like your calculator gave you 61/4. Now, if I want to change it to a mixed number, that is a division problem. 4 into 61. 4 goes to 61. Well, 4 goes to 6 one time. With the remainder of 3, 1 comes down. 4 goes to 31. Looks like, sorry, that's a remainder. That should be a 2. So try that again. My math isn't so sharp there. Let me back up here. So 6 minus 4 would be a remainder of 2. The 1 comes down. 4 goes to 21. That would be like, what is that? 5 times. And 5 times 4 would be 20 with the remainder of 1. So I should have 15 and 1/4 as an answer. If you're going to use a calculator, if you have that 61/4, I can use a calculator to change that to a mixed number. What you can do is you can go green. See, if you hit the second button, and then if you hit that times 10 the end key, it'll do what's above there. And then if you hit the enter key, it should change that into a mixed number for you. So if you have that 61/4 there, if you use the second button and use the times 10 the end key, you'll see right above there, there's this n over d. Then you got these little arrows, un over d. That actually changes a fraction into a mixed number if it's an improper fraction. And remember, improper means the numerator is bigger than the denominator. That means it's more than 1. But yeah, that's the way we can do it on a calculator. Is the second button, hit the times end key, and then hit the enter, and it should change it into this 15 and 1/4 for you. So that's an advantage of a calculator. On number 44, if I can kind of bring this up a little bit. Can't bring it up too far. Okay, I'm going to have to erase some of the math here. Forgive me. So on 44, again, you'll have the GD formula sheet. So the formula will be given to you for volume. Volume equals pi times r squared times h. If the radius is 10 inches and the height is 2 feet, find the volume. Notice there's a hint here. 12 inches is equal to 1 foot. There's a reason for that. If you're trying to find volume, the unit of measurement has to be the same unit. So everything either has to be in inches or everything has to be in feet. It's actually easier to change feet into inches. Since there's 2 feet, we know that 2 feet would be the same thing as 24 inches. So what happens here is you can't use the 2 feet. You got to use 24 in place of that. So your formula should actually be 3.14. Notice that the 10 is in the radius, so 10 squared is correct. But then you actually got to multiply not by 2, but by 24. And that would be the math in that problem. So if I use my calculator here, 3.14 times 10 squared times 24, I should get 7,536. So 7,536 cubic inches would be the volume of that. So the next thing we want to look at is lesson 8. The first few questions, 4, 5, and 6, are dealing with ratios. Again, a ratio is comparing two numbers either with the word to, or we're using a colon, or we're using like the fraction bar, so that top and bottom number. So a lot of times in the question you'll see that word to that tells you that you're talking about ratio stuff. So if I look at number 4, it says Dale's monthly income is $1,800. If you spend $600 on rent each month, what is the ratio of rent to monthly income? And notice there's a hint here. Be sure the ratio is in the correct order. So it's got to be in the correct order here. So notice how in the question it says, what is the ratio of rent to monthly income? So it actually said rent to monthly income. That order cannot be changed. So the rent has to go first and the monthly income has to go second. And it says $600 is spent on rent, so the $600 should be on top. To then the monthly income would be $1,800. So in our ratio, it should be 600 over 1,800. And again, we can let the calculator reduce this, and we should get then 1 to 3. Or again, if I drop the zeros out, you'd have 6/18, and that would still give me this 1 to 3, or 1/3. Okay, so notice how you had 1,800 over 600. That's not the correct order that they asked for. They wanted the rent on top and the monthly income on bottom. So watch out for that. That just because the 1,800 is first here and the 600 is second here, the question itself says rent to monthly income. So I should have it as 600 over 1,800. So order does matter when you're writing a ratio, so pay close attention to that. Number 36 is another one that we're looking at. So here we're getting into percents. So I'm going to go ahead and scroll this up here, and I'm going to make this math disappear. So in percent problems, remember there's 3 methods. We have 3 strategies basically to do percent problems. We have the proportion strategy, which says, you know, the part over the base equals the percent over the 100. There's the formula that says the percent times the base is equal to the part. And then there's also the triangle model. The triangle model is kind of a shortcut strategy that the GED teaches. So the part is here, the base is here, and the percent is here. And when you do it this way, you got to remember that the part and the base are going to be related by division. The part and the percent are going to be related by division. The base and the percent are actually going to be related by multiplication. So we have that kind of going on there in these problems. So those are our 3 strategies that we can use in solving percent problems. Remember, whatever the percent's about is going to be describing the part. And the base is usually the whole amount, or what we also call as the initial amount. So if I look at question 36, Lily pays $3 sales tax on a $50 purchase. Find her sales tax rate for her state. Again, hint, when using the formula, you will need to change the decimal to a percent. So if I'm using this model or this model, I got to remember that my answer is going to be in a decimal form, and I still got turned into a percent. So again, I'm going to use the triangle model. And what I pick up on is the sales tax rate. Notice that the rate is another word for percent there. A rate is a percent. So I'm looking for the sales tax as a percent. And what they give us is, notice that the sales tax, that kind of goes along with the rate. That's the part. That's the part you pay. And $50 is your full purchase. So I'm going to pay $3 in tax for every $50. What I want to do is I want to find what the percent is. And remember, if it's the part and base involved, that's a division problem. So I can type in 3 divided by 50 on the calculator. And that's going to give me 0.06. So when I type in 3 divided by 50, that actually gives me 0.06. So, and remember the hint says you'll need to change the decimal to a percent. So I still got to move the decimal 2 places to the right to make it a percent. So it's going to be then 6%. So that would be the answer to number 36. It's just a 6% tax rate. If I look at 37, Keegan's total payroll deduction is like 30% of his earnings. If his deductions add up to $369 for a two-week period, then how much were his earnings for the period? So again, my strategy I like to use is the triangle model. Again, I need to know what the part is, I need to know what the base is, and I need to know what the rate is, or in other words, what the percent is. It's pretty clear the percent is 30%. Now again, if I'm using this model, I actually got to change the percent back into a decimal. So I got to move the decimal 2 places back to the left to make it a decimal. That's the most common way they're going to do it on the GD test. Now your calculator, you don't have to really do that, but that's going to be actually 0.30. So the percent's going to be this 0.30, or just 0.3 if you want. Now what I got to figure out is the $369, notice that that's the deductions. That's the part that's actually coming out of my paycheck. So the 369 is here. And what I'm actually looking for is my whole paycheck, my earnings. So that's going to be the unknown in this problem. So that means the 369 would have to go here. And we don't know what goes here because that's the base. And remember, the part and the percent are going to be related by division. So this tells me to find the whole amount, I have to divide 369 by 0.30. So if I divide 369 by 0.30, I end up with $1,230. So $1,230 would be the result of that. And that's actually going to make it that, it's actually going to be C. Now remember also, A is not a really good answer because it's asking for your earnings. Your earnings have to be more than $369. So really, A and B are not even really good choices because your total paycheck has to be more than your deductions. So that's where reading and comprehension comes in. So really only C and D are even the logical choices there. So we'll look at a few more problems on number 8. So again, number 40, we have Hank's baseball statistics are in the table. To the nearest percent, what percent of Hank's at-bats were strikeouts? So again, in solving this problem, I still need to identify the part, the base, and the percent, the rate. We don't know the percent. That's what we're looking for. What percent of Hank's bats were strikeouts? That's the unknown. So if I'm using the triangle model, we don't know the percent. At bats, because again it said what percent of Hank's at bats were strikeouts. At bats is the number of times he was at plate, so that's going to actually be the base. That's the 410. That's the total times he was at bat. And then this is what actually happened when he was at bats. He got part of it was hits, part of it was home runs, part of it walks, and part of it was strikeouts. And the part they're interested in is the strikeouts. So the part that we use is just the 63. They weren't interested in the walks, the home runs, or the hits. So the 63 would go here. And since we know the part and the base, and we're looking for the percent, this tells me to divide. So using my calculator, I would divide 63 by 410, and that's going to give me 0.153. So remember, that's in decimal form. You still got to move the decimal 2 places to the right to make it a percent. And it says to the nearest percent. So 15.3%, is that going to be closer to 15% or 16%? And to me, that's going to be closer to 15%. So that's why we should have chose C as our answer, because 15.3% is closer to 15%. So this is our interest formula. Again, this formula is on the GED test. Again, I stands for interest, P is principal, R is rate, and T is time. But remember, T has to be in years. So remember, this is a true statement. Time does have to be in years if we're using this on the GED test. So Lee borrows $1,500 for 2 years at 12% rate. Find the simple interest. So if we look at that one, that's going to be 1,500 times 2, and then you can change your percent to a decimal, 0.12. But again, your calculator, you can leave it as 12%. So if we look at that one, we get 1,500 times 2 times 0.12, and we do get, we end up with like 360. So 360 should be the answer to that one, not 250. Now my next question is, Rick borrows $1,850 for 8 months. So this is $360, not 250. Now number 43, Rick borrows $1,850 for 8 months at 12% simple interest. What is the total amount he will pay back at the end of the loan? So this has a couple of pieces to it. I want to know the total amount he will have to pay back. So he borrows $1,850, so he's going to have to pay back $1,850 plus interest. So to solve this problem, though, I still got to figure out what the interest is. So my principal is the $1,850. My rate is the 12%, so it's going to be 0.12. And then my time is going to be in months, but we have to have years. So to convert that to years, I can use 8 over 12, because 8 months is a fraction of a year, or 8 out of 12. So in that one, you actually got to use that 8 over 12. So if I put that into the calculator, I'm getting $148. So that's going to be interest. I still got to add that to the 1,850. So 1,850 plus the 148 is going to be how much he has to pay back altogether. So he's actually got to pay back $1,998. $1,998 is what he's going to have to pay back on that one. So notice how the time is in months. I got to change time into years by making it a fraction. 8 months is 8 out of 12. So a fraction of a year. Number 44, Jock recently moved from a part-time job to a full-time job. Because the change, his weekly pay went from $288 to $448. To the nearest percent, by what percent did his income increase? Hint, be sure to find the increase in salary, and the base amount will be his original weekly pay. So the hint helps us out here a little bit. So I'm going to come over to the side and draw my little triangle. We don't know the percent, The increase is going to be the part that the salary went up. And to find the increase, well, it went from 280 to 448. So if I take the difference between that, that would give me the increase. So 448, take away the 280, gives me then this 168. That's going to be the increase for the part that it went up. And then it says the base amount will be the original weekly pay. Well, the 280 is his original weekly pay. It went from 280 to 448. So the 280 was what he started out at. And then to find the percent, this is a division problem. So I have to divide 168 by 280. And that's going to give me this 0.6. Now, I still need that to be in a percent notation. So 0.6, I still got to move the decimal 2 places to the right. So that's going to actually turn into then 60%. So number 45, the Durrell's rent increased from $600 to $636 per month. By what percent did the rent increase? This problem is very similar to 44. So again, if you want to pause the video and see if you can kind of follow the same hint. So I'm going to go ahead and work it out. Again, to find the percent increase, I actually got to find the increase. So again, I'm going to use the triangle model. Don't have to be perfect. Just give yourself some spots here. So it went from 600 to 636. So that means really, I can just see that math. That's a $36 increase. And remember, the base amount has to be the original amount, which was the $600. So since I have the part and the base, they're related by division. So to find my percent, I just divide that out. So 36 divided by then the 600, that gives me 0.06. But remember, that's in decimal form. I still got to change that into a percent notation by moving that 2 places to the right, which would be then 6%. Again, you also have on your calculator above the parenthesis there, 0.06. You also can use like the second button. And if you hit the right parenthesis, or what we call the close parenthesis, right above it, it'll actually convert to percent. And then all you got to do is hit the enter button, and it'll do that for you. So if I type in that 0.06, hit the second button, hit that parenthesis, it'll change it into a percent by hitting enter, and it'll just give me that 6%. So you can change decimals to percents on the calculator if you wanted to. So that's a little bit of a review of some of the percent stuff. So in lesson 9, you did it really good on most of that. There was a question again that looked like this. I don't think I got the whole question on there though, because I think there was a graphic. So by what percent did the orders of the National Shipyard decrease from 2008 to 2009? And by about what means, again, there's a hint there. By about what means the numbers don't have to be exact. To find the percent decrease, find the actual decrease between the years, and then divide by the original amount of ships sold. Remember, the decimal answer will still need to be changed to a percent. So that's a mouthful still. Let me pause this, and I need to pull up the actual worksheet as well. So on the worksheet number 2, we had this graphic up here. By what percent did and this is again lesson 9, by about what percent did the orders of the National Shipyard decrease from 2008 to 2009? And again, there's a hint there that said by about what means the numbers don't have to be exact. To find the percent decrease, find the actual decrease between the years, and then divide by the original amount of ships sold. Remember, the decimal answer will still need to be changed to a percent. So again, I can use my little triangle model here. again, we're looking for the percent, so we need to know the part in the base. The part is actually the decrease. So 2008, it looks like it's around 650. And then 2009, it looks like it's around maybe a little bit, maybe 390 if you want to kind of fudge a little bit there. So, or 400. So what I got to do is to find the decrease, just subtract those numbers. So 650, take away 390, that's going to give me like 260. So that's how much it decreased by. And remember, your base is always the original amount. And remember, 2008 is the original amount, and then it went to 390. So I got to use the 650 here. So it's a 260 and then a 650. So I got to divide the 650. I got to divide 250. Try that again. 260 has got to be divided by 650. And on my calculator, I'm getting like a 0.4. So remember, I still got to change that to a percent by moving the decimal 2 places to the right. So if I have a 0.4, if I move the decimal 2 places to the right, that should give me then this 40% as the answer. So that's how that one would work out on that page. Okay. See if there's anything else there. No, looks like that's all there was on lesson 9. So this brings us to lesson 10. And so in lesson 10, you went and redid the problem, so you picked up on your mistakes with number 1 and number 2. So you recognize that, hey, I should be adding a 7 on both sides there as opposed to that 5. So you redid those two nicely. Now if I move to question 3, you have this 2, and then in parentheses x plus 3 is less than 4. So remember, you got to remove the parentheses. So you got to multiply the 2 through the parentheses. That's going to give you 2x plus 6 is less than 4. So notice how your first step is perfect. You distributed through the parentheses perfectly. You saw addition, so you need to subtract 6 on both sides. So I have 2x then, and the 6's will zero out, is less than, and a 4 and a negative 6 would be then a negative 2. So 4 minus 6 would be a negative 2. And then you got to divide by 2. So I should have x is less than a negative 1. So somewhere along the way, it looks like you may have lost your negative symbol, because I should have had a negative 1 there instead of a positive 1. So that's where a careless mistake got you. On number 4, you have negative 2x plus 9 is less than 1. Again, we have to get the x by itself, so we go after the 9 first by subtracting 9 on both sides. So it gives me a negative 2x, and that's going to be less than a negative 8. And then we got to divide both sides by negative 2. And this is where there's a catch with inequalities. If you divide both sides by a negative, the inequality sign actually has to change directions. And that's more in the educational videos that I sent you. So this is one of the tricks to solving inequalities is in getting x by itself, if you divide in that last step, if you divide both sides by a negative number, you're required to keep it true to switch the sign. So instead of a less than symbol, it's got to be a greater than symbol. And a negative divided by negative is going to then be a positive 4. And that's what's wrong with your math here is when you divided both sides by negative 2, that sign should have changed. That was the only mistake you made on that one. Number 5 you did correct. Even though that should be like a 3x there, you understood your math. So 5 you did perfectly. 6 is a little bit different. Let me clear this out here because 6 requires a little bit more of space. So in 6 I have this 3 is less than 5x minus 27. This is called a compound inequality. if there's a compound inequality, what that means is you actually have two inequalities. So this here makes the first inequality. So I have 3 is less than 5x minus 27. And the other one is this over here, 5x minus 27 is less than 53. So actually we have two inequalities to solve for x. That's what's called a compound. Notice how there's this double inequality. So again, to get x by itself, we see subtraction. We got to add a 27 to both sides. That's going to give me my 30 is less than 5x. And to get x by itself, we just divide both sides by 5. So that's going to give me 6 is less than x. And then if I solve this one, you got to add a 27 to both sides. That's going to give me 5x is equal to 80. Yeah, 80. I'm sorry. I was going to put down 90 there. Let me clean that up a little bit. That's actually an 80. And then if I divide 80 by 5, because you got to divide both sides by 5, and again, I'm sorry, that's a less than symbol. So I have to divide 80, I have to divide both sides by 5. So 80 divided by 5 gives me then 16. So x is less than 16. Then if you put these all back together, you have the 6 is less than x, and then I wrote down the x is less than 16. So you can just bring it back together as a compound inequality. So you can kind of break them apart, solve them, and then put them back together. That's kind of the strategy you can do on that one. There are other ways to do it, but that's just the way I showed it in my videos. So hopefully these, going over these questions may help review you a little bit. Again, feel free to watch these videos more than once. And I will leave you with that. Good luck, Amanda.